another section for the final exam. Last term printed theirs on yellow, double-sided. And then he was just going to recycle them right away. And I was like, no, I'm teaching this again next term, so I'll just reuse them. So these have been through a final. If only they could talk, right? Just ask them what was on the final. So if you're just joining, you grab the formula sheet. I'll just put them up here. Okay. But for the test, I have another set. Of course, I printed some too. You'll have the exact same formula sheet. It's just not on yellow paper and double-sided instead of single-sided. So, but same thing. So you'll have all that information on the test. So the yellow one, that's yours to keep. Do whatever you want with. And then for tests, you'll have to use my formula sheets, but they're the same. So, no. So that's what you'll have. So anything beyond that sheet that you need, you'll have to learn that. In general, it's pretty comprehensive. Okay. What's the chatter? Questions? No? Slacking? Okay. So, chat. Brenna, are we able to get a yellow sheet? Yeah, you are. I almost said yes. You bet. How about that? Oh. It won't let me close. There we go. So you can have a formula sheet later on if you're not here. Okay, so I think we're recording great. Let's get started. We almost finished chapter 2 last day, right? So let's just work through. I'll just kind of scroll through the example that we did last day and then as a review, and then we can tidy it up and finish it. So I'll actually add it to last day's notes. So we talked about lots of things, but the main thing that we led up to was linear programming. And so linear programming was if we have some constraints, right? So we don't have unlimited machinery, we don't have unlimited hours. And so we have these constraints that we have to deal with, but we still want to maximize our profit function. And so in this example, we were given this profit function, x plus 1.2y, and then subject to these constraints were what we were dealing with. Okay. And so what we said, so there's steps to linear programming. First thing we're going to do is we're going to map out all these constraints on one graph, right? And so that's where we're applying, well, that's why we had to learn how do we draw a straight line, for example, right? That kind of thing. And so we draw all these on the same graph, and then we identify the feasible set. So we go from the center, 0, 0, and then we go out until we hit a line. All of those points in that area make up the feasible set. And those are just all the possible XY combinations that we could have. Okay? But as a fact, our profit function will be maximized at one of the points of intersection. Right? So of the feasible set, you're now going to find the points of intersection. So that's why we had to figure out how do we solve systems of equations, right? That's finding points of intersection. And so then we found points of intersection. That's kind of where we left off. But in terms of where we're headed, right, you're going to find the points of intersection. And then at those XY coordinates, right, you're going to evaluate the profit function. And whichever one gives you the highest profit function, that's the point that you'll pick. Right? So we got so close, right? So we had these constraints that we were dealing with. So first we solved for y, right? Each of these, we kind of ignored x has to be greater than 0 and y has to be greater than 0, right? We can just kind of ignore those and just focus on the first two. So we solved each of them for y just because it makes it easier to look at them and deal with them. Then we said to graph a straight line, we need 2 points on the line. So any 2 points, pick convenient values of x, right? And so for the first one, we picked 0 and 50. You could have picked any values, right? And then for the second one, again, we picked 0 and 30. Why not? Okay. And so then we went ahead and we drew those points. Of course, our graph isn't quite as beautiful as it could be because I just drew these ticks on there, right? And we did together. On the test, when I get you to do this, I'll give you the axes, so you won't have to deal with that. Then you can just plot your points. I also mentioned last day that this stuff, this linear programming stuff, I'll test on test 1, and then it won't be on the final. So it won't be on the final, but it will be on test 1. So then, once we drew our lines, right, we were able to see, okay, well, starting from here, we can sprout out until we hit a line, and that's what we call our feasible set. And then we said, okay, well, let's just identify all the points of intersection of the feasible set. So we start here. 0, 0 is always an intersection. It'll never maximize your profit function. Basically do nothing, right? But it's an option. This point, right, is 0, 100. Right, we know that. This point we had to solve for, and that's where we ended. Right, we found C, which is the intersection of line number 1 and line number 2, essentially solving that system of equations. And then now we have to find D. Okay. So, any questions before we get started? Great. So I like to just make a table, right, kind of to summarize where like all the information that I have and what I need, right? So here's my points of intersection. I just list them A, B, C, D. And A is at 0, 0, B is at 0, 100. So I don't need to find those. I know those already. And then C, we said, is the intersection of 1 and 2. If we've labeled line 1 and line 2. And D is the intersection of line 1 and y equals 0. Right? Because y equals 0 is the x-axis. Just like the y-axis is where x equals 0. So we solved for C. Right? We said here's line 1, here's line 2. We want to find the intersection of these two. And so we went ahead and we moved some stuff around, right? Set them equal to each other. And eventually we found that x is 48, which we could then substitute back into y to solve for y. And we found that y is 84. Right? So that's where we ended. Now we can solve for D. So I'll just say here, this is January 21st. Continued. And then for chapter 3, I'll start a new set of notes, but just so we have it all in the same place, otherwise it gets confusing. Okay, so now we can solve for D, right? And from our note, D is the intersection of line, is it 1 or 2? Of line 1, you could either look at the graph, or if you made one of these tables, then you can just go from the table, right? At the intersection of line 1 and y equals 0, of 1 and y equals 0. I'll just flip to that section so I don't have to keep scrolling back and forth here. So we have y is 180 minus 2x. That's line 1. And where it intersects y equals 0. This is kind of a nice solution, right? Because we know that y has to be 0. So we only need to solve for x. So we can set these two equal to each other. Right? Y equals this, y equals this. Force them to be equal. So now we're saying, okay, well, 0 must be 180 minus 2x. Solving for x and also avoiding negatives. I'm just going to move the negative 2x over to the left-hand side. Right? That makes it positive. So now I have 2x is 180. Because I'm trying to get x on its own. And so x must be 180 divided by 2. So x is 90. So now we know where this line crosses the x or the y, yeah, the x-axis. I had it right the first time. The x-axis, right, is at x equal to 90. Okay. So, and recall that y is 0, because that's the line where we're trying to find it. So D is at 90, 0. So now what we can do, right, now we have all these points of intersection. And so if we make a table of all the points of intersection and evaluate the profit at each of these points, we'll be able to see which one has the highest profit, right? And that's your maximized profit. Okay. So now we make a table of all of our points of intersection. Points of intersection to solve for the profit at each point. The largest profit will, of course, be the maximized profit. Kind of goes without saying, but will be the maximized profit. So if we make a table, right, here we've got our point A, B, C, and D. A was at 0, 0. B was at 0, 100. C was at 48, 84. Confusing. 48, 84. And D we just found was at 90, 0. And I'll just make a little note, right, in case you've forgotten. Oops. We always write these pairs as x comma y. Right, so the first one's the x, second one's the y. So here, can separate these. We know that p, the profit function. So notice this is the first time that we bring the profit function back in. Right, so we just ignore that profit function until the very end, where we're trying to plug in our values of x and y to figure out which one maximizes it. Right, so you just ignore it until this point here, which is at the very end. So p equals x plus 1.2y. So if you have here, so the profit at A is 0 plus 1.2 times 0. I'm going to go ahead and say it's 0. There's very rare circumstances where you actually, that might be your maximized profit. It's not a good place to be, right? Where doing nothing gives you the most amount of profit. Probably want to change some things, but it could be an option. So the second one, x is 0 plus 1.2 times 100. Y is 100. Gives us a profit of 120. C, x is 48 plus 1.2 times 84, which I've just got here, is 148.80. That's higher than 120, right? So that's good. We'll check the last point. X is 90 plus 1.2 times 0. That just gives us 90. 90 plus 0. So here, our profit is maximized when x is 48 and y is 84, and our maximized profit is 148.80. So our profit, showing up so you can read it good. Our profit is maximized to 148.80 when x is 48 and y is 84. It's a lot of 4s and 8s in there. I don't know. I didn't make it up. So that's a big kind of problem to have to solve, right? But the reason I put it on test 1 is because it tests, do you know how to solve systems of equations? Do you know how to draw straight lines, right? Do you know how to, what else do we do in here? Find points of intersection, right? So it tests a lot of these things that we need to know how to do. And so that's why I like this problem, because it kind of pulls everything together, makes you do all the things that we've covered so far, essentially. Any questions about that one? Okay. So I'll start these kind of fresh notes for today then, because now we're going to start chapter 3. So no questions about chapter 2. I plowed through it last day. Great. So chapter 3 is, it's called business economics. I don't know how helpful that is. Business economics. And I usually cover 3.1, but today I might leave it for another day just because we might not need it. And the reason that I'm maybe not too keen on getting into it is because, well, if we don't need it, it's just introducing you to a little bit of calculus, which everyone's kind of like, oh, unless you've taken calculus, then you're fine. Has anyone taken calculus? Yeah, great. So we're gonna do, eventually we'll do little fake calculus things, okay? But we won't spend a lot of time on it. And the way the textbook is set up is it introduces it here, we go do something else, and then we pull it back in. So that's why I'm kind of putting it to the side for now, and we'll start in 3.2, and then we'll come back to 3.1, but I'm just gonna pick out what we need, nothing that we don't. Okay, so we will skip 3.1 for now. And leave it until we do 3.4. Leave it for when we do 3.4. So feel free to read through it, but it's not something that we're going to talk about until 3.4. I just think that that makes more sense to do it in that order. 3.2 then. Oh, wrong page, that's why. 3.2 is on merchandising. And oh, there it is. Anyone not have a copy? Yeah. Anyone else? Nice. So 3.2 is called merchandising, which is also the first section on your formula sheet. So this is the first part where we kind of head into the formula sheet, and that's why you got it today. So merchandising. Uh-oh. Try to charge it while I'm talking here. Okay. All these things need to get charged all the time, and I feel like I'm just constantly charging stuff. It's crazy. Anyways, so merchandising, this first section that we're going to deal with, or really deal with, is, so imagine the scenario. So you run a store, right? You have a store and you've purchased some merchandise, right, from some supplier, right? And then you're going to sell it for some amount, right? So I think we all know and understand that the amount that the store owner bought this product for is less than what you're paying for it, right? So at each level in this chain, right, the next level pays a little bit more, right? So there can be multiple levels, right, of the supply chain, right? So the first manufacturer sells it to someone for some amount, they sell it to someone else for a little bit more, they sell it to someone else for a little bit more, right? And so they're constantly taking their cut, right? And so in the supply chain, right, there's kind of a change in price going on, right? And so that's what this merchandising section is all about, right? We're going to talk about the selling price versus the cost, right? So the cost to me as someone who runs a store is different than the selling price that I'm selling it for, right? And what's the makeup of all those numbers. Okay. And so let's see if this charged a little bit more. I need to write now, so nothing I can do. We'll start with just talking about some definitions that we need. Because if you're looking at your formula sheet, right, there's a lot of shorthand on here. N, L, lowercase d, S, C, M, all these things. And so in the beginning here, what I want to do is just introduce you to all these terms, right? And then knowing what they are will help you figure out how to use these formulas. Right? And so we will start by introducing some of the variables on your formula sheet. Some of the variables on your formula sheet. I guess we can just read across. Let's start with N. N is the net price. That doesn't really tell you anything, right? But let's just write it down. So the net price, is the price to acquire the product, right, at each level of the distribution chain, right? So if I'm the store owner, right, the net price is how much did it cost me to get this product, right? But like we just said, each level in the supply chain, it's going to have its own net price. Okay? And so, yeah, at the store level, the net price is the same as the cost, right? The cost to me. But because we can have multiple levels in our supply chain, the net price is just in general, how much did it cost for you to acquire it, depending on where you are in the supply chain. So it's the price to acquire the product at each level of the, I think I've been calling it the supply chain, but we could also call it the distribution chain. So that's N. Next thing on our list, if we're just reading kind of left to right across the page here, we've got a capital L. So a capital L is the list price. So the list price is the suggested retail price, right? So it's the suggested price. So the manufacturer says, oh, I think that you should sell it for this. And so often how it works is they've got some suggested retail price, right? And then they'll say, oh, I'll give you the list price less 50% or something, right? Give you a discount on this list price. The list price isn't necessarily the amount that you sell it for. It's just what is the manufacturer thinking that you'll sell it for roughly. So it's the price at which a product is suggested to be sold at. Suggested to be sold at by the manufacturer. So an example might be books, right? Books always have the price, Canadian, US on there. and they're printed on the product, right? So they're saying, this is how much this book costs. Take it or leave it, right? And so that's the list price. But bookstores just say, oh yeah, that's how much we charge, right? They could put it on sale or do something crazy like that, but in general, they're selling it at the list price. But it's really up to each store what they want to sell it at. Okay? So that's your L. The lowercase d is a discount. It's a trade discount. Right? So in the scenario where the manufacturer says, oh, I'll give you 30% off the list price, right? That would be your D, your trade discount. So D is your trade discount rate. So this is a discount, and like we said, right, if you work backwards from us, we're the end consumer, right? We buy this product in the end, right? But the store owner that we're buying it from got it at a discount compared to us, and then wherever he bought it from got it at a discount, right? And so we could apply these discounts going back to the core manufacturer. So a trade discount rate, or is it a discount applied at each step of the distribution chain? At each step of the distribution chain. I guess I called it supply chain. Doesn't matter. Okay. But you'll see if you scoot over one, right, to the next formula, again, we have N and we have L. Those mean the same thing, right? But then we've got D1, D2, D3, right? So those would apply if there's more than one discount, right? So if you have multiple discounts, you've got D1, D2, D3, and you just apply them in this formula. And you can just keep going until you've covered all your discounts. Okay. So if there are more than one discount, right, or trade discount rate, we denote them by D1, D2, D3. We denote them by D1, D2, D3, etc. You can have as many as you want. So let's just do a little example. I'll write out the formulas that we have on our formula sheet, right? And so we have the net price is the list price times 1 minus the trade discount. So in terms of a formula, right, we've got N is L times 1 minus D. Or with multiple discounts, we've got N is L times 1 minus D1, 1 minus D2, 1 minus D3, blah, blah, blah. 1 minus D sub K. K can be anything. or any number, I should say. I'll try to remember to just kind of put some boxes around what's on your formula sheet. I'll try to remember. You guys can remind me if I forget. But because we're introducing a lot of new formulas here, it's nice to know which ones are on the formula sheet and which ones aren't. They should all be on the formula sheet. So let's just do a little example. So if we do example 78, and what you'll find is that I've got them, I took these weird pictures here, but that's why it might be helpful if you have your textbook, or I'll read them. I always read the examples too, but so we'll just be doing example 78 in the textbook. So I'll steal it from here, because I have to hold the page and take the picture. It's always a little bit wavy, but yeah. I think this is the first time that I'm doing this in this class, so this is how the notes will be made up. So in the notes, I'll have the example in there, right? But if you just write example 78, you know to look in your textbook. Right? So Rawlings is offering a trade discount of 38% off bats to sporting goods stores. What will be the cost to a sporting goods store to purchase a bat listed at $135? So here, right, we're told that the list price, right, listed at $135, so the list price is $135. And then we're told that the discount, right, the trade discount is 38%. So here, I'll just make a list of what we're given. We're given that the list price is $135 and the discount is 38% or 0.38. I think we kind of touched on it last day, right? But whenever we're doing any calculations, we'll need to convert our percentage to a decimal, right? We saw that in an example, but now it's going to be really important that we use the decimal instead of the percentage. So eventually, I won't even write the 38%, I'll just write 0.38. Right. Just kind of skip straight to it. So there's only one trade discount, 38%. We know how to deal with more, but we'll start with just one. And so now we want to know what will be the cost to the store, right? That's the net price. So we want to find the cost to the store, which is the net price. From our formula sheet, we know that N is L times 1 minus D. So we want to find N. N is L, so 135, oops. 135 times 1 minus 0.38. So N is 135 times 0.62. $135 times 0.62. I get $83.70. So in this case, it works out to a nice number, right? 8370. But remember, you're going to keep all your decimal places until the very end. And if you're talking money, that's the only time that you can round it to 2 decimal places, right? Or should round it to 2 decimal places. So, any questions about that one? Ooh. Let's do another example. Let's do example 80. So TI calculators are sold to the retailer at a net price of $32.15 per calculator, right? So now we know the net price, while the retailer sells the calculator for the list price of $43.95. So we know the net price and we know the list price. What was the trade discount given to the retailer, right? So what is D is what we want to find. So again, I'm just going to list what we've been given here. So we're given, oops. We're given that the net price is $32.15 and the list price is $43.95, and we want to find D. What was the trade discount given to the retailer? So we can use the same formula, right? Just rearrange it if we want to solve for D. So we've got N is L times 1 minus D. I'm going to plug in my values. If you wanted to, you could rearrange this formula, solve it for D. I just find it a little bit easier if I just have the numbers in there already, and then I can move it around and solve it at the same time. All right, so I'm going to put in my values. 32.15 is 43.95 times 1 minus D. So if we're trying to solve for D, right, we're going to divide both sides by 43.95. And that's our first step. So we've got 32.15 over 43.95 is 1 minus D. The 1 minus D doesn't have to be in brackets anymore because it's not being multiplied by anything. And so nothing's happening in there, so we can just write 1 minus D. And then if we do 32.15 divided by 43.95, we get this kind of nasty number. 0.731513083 is 1 minus D. Did I show you guys how to store stuff yet? Not yet, right? It was a bit of, yeah, but I think yeah. Anyways, it's really handy. So here we go. So you want to keep this whole number, right? That's what I've been telling you. You have to keep all your decimal places, but you don't want to type it in again, right? And so what you can do is there's a store function, right? STO. And then, so what you do, you have the number on the screen that you want to save, right? And then you'll hit the STO, so store, and then tell it which little pocket you want to store it in. So you can use any of the numbered buttons, right? Store in 1, for example. It won't do anything. But now if you clear it, then if you hit recall, so RCL, recall 1, it'll pull that number back up for you. So now I've stored it in 1 and I've got that number in there. So for any kind of nasty numbers like this, right, you're going to do 32.15 divided by 43.95 equals. And then you're going to want to store this. So store in 1, for example. you can store in all of the numbers. You just have to remember where you stored things. That's a problem on its own, right? For that reason, I'm going to write store 1, just making a little note to myself, really, where I stored this, so that if I have to store a bunch of things, then I can remember where I stored that number. Cool. Is anyone not getting the store recall? It'll be very handy. So if it's still not working, then just come see me after class and I'll show you. Okay, so now we've stored this in 1. And we want to solve for D, right? So we want to move the D over to one side and all the numbers over to the other side. Because I don't like dealing with negatives, I'm going to move this D over to the left-hand side and move my 0.7 over to the right-hand side. Right. So it becomes D is 1 minus 0.731513083. So 1 minus recall 1 equals 0.268486917. So D is 0.268486917. You have to hit the equal sign, otherwise it'll just show the recall one. But that's going to be very handy when we can store things and recall things. So now we can round D. D is 0.268 or 26.8%. Any questions about that one? Yeah.
Just one question about this, but when it comes to the test, do we have to do it the way that you showed us, or do you know another way of doing it? Would that be okay?
Oh, if you know another way of doing it, that's great. Yeah. As long as you show me kind of your logic.
Yeah.
Okay. That's good. Yeah. Nice. So let's do another example. Why? Well, we haven't seen an example with multiple trade discounts. Whoa. It's got this fun wave. Rona can purchase bags of soil. It's got a little bit of attitude. So Rona can purchase bags of soil from their distributor for a list price of $3.25, less discounts of 25% and 10%. Right? So what we'll see, I feel very confident, is that 25% and then 10% is not the same as 35%. Right? So first the trade discount of 25% and then 10% off that. Right? So it's different. So again, I'm just going to list what I've been given here. So I'm given the list price is $3.25. Okay. And now I've got 2 discounts, so I'm going to do D subscript 1 is 25% or 0.25, right? That's the value I'll be working with. And then the second discount is 10% or 0.1. So we want to find the net price, right? What is the net price that Rona pays for a bag of dirt? So we want to find N. So we've got N is the list price times 1 minus D1 times 1 minus D2. right? We only need to put as many as we have discounts. We only have 2 discounts, so we can stop there. We have to stop there. So trying to find N, we've got a list price of $3.25, and then times 1 minus 0.25, and then times 1 minus 0.10. You want to be careful, because a lot of the time I see people get carried away and they forget the 1 minus, right? And so 1 minus 0.25, that's going to be replaced with 0.75, right? So if you went ahead and just used the 0.25, that's not going to work out. So this becomes 325 times 0.75 times 0.90. So we've got 325. Because we're multiplying all the way across, we can just do it in one go, right? Multiplying and dividing we can do in any order. So 325 times 0.75 times 0.9, we get 2.19375. So N is in monies, right? So $2.19. What would I'm just going rogue here. What would the net price be with a discount of just 35%? Right, so just to compare the two. So what would the net price be with a single discount of 35%, right? Because that might be tempting to just say, oh, well, 25% and 10%, I'll just smush them together, 35%, that's got to be the same, right? But let's just see what it is. I promise they're not the same. Okay? So it's kind of a warning. All right, so now I'm just going to cheat a little bit and skip straight to it without listing all the information again. Now we've got N is the list price of $3.25 times 1 minus 0.35. 325 times 0.65. $3.25 times 0.65 is 2.1125. So N is $2.11. What's the big deal, Emily? Talking 8 pennies. I know. But what if those pennies were millions? Yikes. Right? So you want to be careful, because 2 consecutive discounts are not going to be the same as 1 single discount, right? We'll be able to find, right? Or you could probably even guess right now what it might be, right? We could combine these 2 to find the discount that's equivalent to these 2. That's what we'll do later on. Right? You could figure out, well, what do I need? I need 1 minus something to be the same as 0.75 times 0.9. Right? So we can kind of work that way. But like I said, we'll parking lot that for a little bit. But here's kind of the takeaway, right? We can't just combine discounts and apply them, right? We have to do them consecutively, 25% and then 10%. Okay. Nice. I guess I did go rogue. Sure, let's do it. I'll just make this one up. So what single discount would we need to be equivalent to the 25% and the 10%? So what single discount would be equivalent, oops, to the 25% and 10% discounts? So there's a couple of ways that we can go about doing this. Right. One way is just to say, well, right, I'm interested in these discounts here, right, the 25% and then the 10%. Right? And so we want to find 1 minus d that can replace 1 minus d1 times 1 minus d2. So essentially, we want to find the 1 minus d that can replace 1 minus d1 times 1 minus d2. Because that's the only difference between one discount and multiple discounts, right? N stays the same, L stays the same. And so we just want to figure out, okay, well, what 1 minus d is going to be the same as 1 minus d1 times 1 minus d2. So you could just say 1 minus d has to equal 1 minus d1 times 1 minus d2. So you could say 1 minus d must be equal to 1 minus, what was it, 0.25 times 1 minus 0.1. So 1 minus d must be 0.75 times 0.9. And 0.75 times 0.9 is 0.675. 1 minus d. Now we have to solve for d, right? And again, I'll move the d over so I don't have a negative d to deal with, right? So I've got 1 minus 0.675 is d. But then I like to have the d on the left-hand side. So whatever I'm solving for, right, I like to throw it over on the left-hand side, kind of like a revolving door. You can move stuff from one side to the other. So d is 0.325. Another function on the calculator that I use quite a bit is the previous answer button. Right, so over the equal sign, there's the answer. So if you go second answer, it'll give you whatever the most recent answer was. So it's kind of like a recall, but it only recalls the most recent answer. So I use that a lot too. So for example, when I had 0.675 on here, I can go 1 minus that answer to get 0.325. Just little tips and tricks you'll learn along the way. So a single discount would be 32.5%. That would be equivalent to 25% and 10%. Therefore, are you guys comfortable with the therefore notation? Anyways, 3 dots in a triangle is therefore. Therefore, a single discount of 32.5% is equivalent to discounts of 25% and 10%. The way we did it here might not be entirely obvious. And I know this is one of the Moodle quiz questions that I'll give you guys. So stay tuned. Right, because a lot of people look at this question and say, well, how am I supposed to know that without any other numbers? Right, so without a net price or without a list price, I'll just show you what I mean. So what we have, right, is we have N equals L times 1 minus D. And we also have that N equals L times 1 minus D1 times 1 minus D2. So in general, right, how did we arrive at 1 minus D must be the same as 1 minus D1 times 1 minus D2. So what we did was basically solve a system of equations, right? N is the same and N is the same. So we could do something like L times 1 minus D is N, which is also L times 1 minus D1 times 1 minus D2. And if what we just did here makes sense to you, then you can tune out for a little bit. Okay, I'm just trying to explain where we got this from. Okay. Saw some relief back there. Oh, phew. Take a break. Okay. So here we're just saying both of these are equal to N, right? So we can cut out the middleman and just say that L times 1 minus D must be the same as L times 1 minus D1 times 1 minus D2. Here's where people have a problem with, but I don't know L. Does it matter? How would you move it from one side to the other? You would divide it, right? Doesn't matter which one you want to move to which side, right? But because they're on both sides, they're going to cancel out, right? And so this is going to cancel and this is going to cancel. And that's how we arrive at 1 minus D must be the same as 1 minus D1 times 1 minus D2. Now you can tune back in. Okay. So that's going to be an important concept, right? That if you have multiple discounts, that's not the same. So the equivalent discount is not the same as just adding all those up and applying those. Okay. So let's talk about markups. You guys are all in business, so you know this idea where, so you run a store and you've got a selling price, and that's going to include the cost that it costs for you to acquire this product, but also some amount of markup, right? And so that's what this M is on your formula sheet, right? So we've got some new definitions. So same idea as when we started. We've got S. S is going to be the selling price. I don't know how to explain that except it's the selling price. So it's whatever you're selling your product at. The price at which the product is sold. Making it even wordier. Okay, but that's your selling price. That's fine. If you are the owner of the store, right, you might sell it at the list price. So then the list price and the selling price would be the same, right? L would be the same as S. But you also have the choice to put any selling price on there that you want. C is the cost. This is the cost to the store to acquire the product. The cost to the store to acquire the product. If you're thinking about the supply chain, right, and you're the store, you're the final frontier here, right, then the cost to you is going to be the same as the net price. Right? So at the store level, the cost is the same as the net price. Okay? So here, I'll just make a note here. At the store level of the distribution chain, store level of the distribution chain, the net price is the cost. So N is C. It's very important though that this only applies at the store level. Luckily for us, that's really the only level that we'll talk about, right? But this product could have gone through lots of different phases of the supply chain before it got to the store owner, right? And each of those would have a net price. But as far as the store owner is concerned, the net price is the same as the cost. So you want to keep those in mind. Capital M is the markup. So this is basically the amount that you make on top of the cost, right? And so I'm not sure how to say the markup without just saying it's the markup. So the markup includes your expenses, your overhead expenses, right? You have to cover those, and also your profit. So the markup includes the overhead expenses, as well as the profit. So on your formula sheet, I'm not going to read from left to right anymore. Now I'm going to read down. Gets a little confusing, right? But because we've got M and then we've got a formula for M, so that's what I want to introduce. So the markup in the formula for M, we've got E, and E stands for the overhead expenses, right? You can think of it as the expenses is the overhead expenses. O was probably taken for something else, but also we don't want to use O's because they look so much like zeros, right? And so that's probably why we've used E's instead, I think. So just think expenses. So these are just the costs to run a store. Any sort of costs that you have to pay, right? You have to pay your employees, you have to pay rent, you have to pay your phone bills, you have to pay all your bills, right? Those things have to be covered, right? On top of the cost to acquire this product, right? So those would be in E. And then we've got P, our favorite one. That's your profit, right? So this is the chunk that you're going to tack on, and that's your, well, that's your profit. So the profit, the profit is just money earned, right? After you've paid for the product, you've paid for your staff, you've paid for your rent, right? You get this little bit of profit in the end. If you don't, you're doing it wrong. You should probably take home some profit. Stop selling stuff if you don't. Okay. So we've got these formulas. So now I'll introduce some formulas here. So we've got S is the cost plus the markup. That one's on your formula sheet. So that makes sense, right? We should S, now it just is a matter of memorizing these things and what they all mean, right? But the selling price, S, has to take into account C, the cost to buy this thing, and the markup. Right? But we've also got M is E plus P, right? So we've got the markup is the overhead plus the profit. So we could just take, right? Usually we'll just want to end up using this in here, right? We can just replace M with E plus P, and that's where we get this third formula. S is C plus E plus P. Where all we've done is just, we've replaced the M with E plus P. Just make a note here. Since S is C plus M, we can write as C plus, and then in brackets, E plus P to denote that they came from M. But then because we're just adding, this becomes C plus E plus P. Just a combination of those formulas. Let's do an example. Let's do example 86. So a retailer of speakers purchases his stock from the manufacturer for $64.29. Right? So that's the cost to him. Right? In order to determine his selling price, he adds 15% of the cost for overhead and 20% of the cost for profit. What is the selling price of the speakers? And so again, I'm just going to outline what I've been given. So a retailer purchases his stock for $64.29. So I'm told that the cost, right, the cost to buy these things is $64.29. And then I'm told that he adds 15% of the cost to account for the overhead, right? The overhead we denote by E. E is 0.15 times the cost. Right? Or if we want, we can just say 0.15 C. Now there's a method to my madness here, because even though we know C in this situation, there's going to come a time when we don't necessarily know what C is. So then being able to write it as 0.15 C is going to be important. And the profit, again, right, is 20% of the cost. So P is 0.2 times the cost, right, or 0.20 C. You can solve this two different ways, right? If you wanted to, you could plug in C because you know it, right? Solve for each of those values. Remember, the goal is to find S, the selling price. We have C, we have E, and we have P. You just pick the formula that looks good. Usually it's going to be the one with the least amount of work that you have to do. And so we've got S is C plus E plus P. So what I'm going to do is I'm actually going to keep these C's, even this one, that top one, I'm just going to keep it as a C, just so I only have to plug in my C once, right? And you'll see what I mean. You'll see what I mean. I know. So we've got a C, right? Which I'm just going to keep as C. I know what C is, but just so I can collect like terms, I'll just kind of leave it to the side. And then, so I've got E, which is 0.15 times C, plus P, which we said was 0.20 times C. So now we've got a C term in all of these. And so we can pull out a common C, right? Factor out a C, and then we're left with 1 plus 0.15 plus 0.20. So we get C times 1.35. Right? Key thing is that you don't forget about this 1, right? Because you've got 1C plus 0.15 C plus 0.2 C, right? So you don't want to forget about that 1 because it's going to make a huge difference. Oh, because here we've got 1C, right? An invisible C. So here it's being multiplied by 0.15 and 0.2. Here the coefficient is technically 1. Right? So that's the one that follows us into here. Right? But now that we only have numbers in here, we can collect them 1. Good. Good, good, good. Now, instead of plugging in C twice earlier, I only have to plug it in once, right? C times 1.35. Because I know what C is. Right, C is 6429 times 1.35. 6429 times 1.35 is 86.7915. So S is $86.79.
So my question is in terms of, because there's three equations that you gave us, but is the main one we're going to be using is S equals C plus E plus B?
Yeah,
Or is it gonna
probably.
be-
It's going to depend on the question, but I mean, if I had to pick one, yeah, I would pick this bigger one that we just used. Right. And just keep in mind that E plus P is the markup portion of it. Good. Yeah, any other questions? Okay. So even though this way might feel a little bit unnatural to start with, right? Later on when we do more of these, it's going to save you a lot of work if you just keep the variables, even if you know it, right? Until you can collect like terms, and then it'll just save you a little bit of work. But like I said, if you wanted to solve for E and solve for P and then just plug them in, that works too, right? I'm just trying to save you a little bit of work, make it a little bit more efficient. But if you get to the end and you got the same answer, you did it. Congratulations. Okay. So, doesn't matter. Let's do another example. 88. This one has a real buckle. Oops. Can kind of follow along. I like thinking of them as like really sassy questions. After a markup of 32% of cost for the overhead expenses and a markup of 37% of the selling price for profit, a car dealer sells used cars for $14,995. At what cost did the dealer purchase the cars? Oh, blah, blah, blah. Okay. So now we have to find C. So we know, again, we're given that the overhead expenses is 0.32 of cost. All right, so I'm just going to start writing them out like that. And a markup of 37% of the selling price for profit. Notice how it gets confusing with the markup and a markup, right? But if I asked you to solve for the markup, right, I'm asking for the total of the overhead and the profit. But here, when I'm saying, or when it says it does a markup, it's just saying it jacked up the price by this much for this portion and this much for this portion, right? So it's just kind of how we word things. So it can be confusing, but just look at, so 32% of the cost for overhead expenses and 37% of the selling price for the profit. So now we've got profit, oops, is 0.37 S. And the dealer sells the cars So we know the selling price is $14,995. And we want to find C. Oops. So again, just take inventory of the things you have, and that will help you pick a formula, right? So we've got C, we've got S, we've got P, and we've got E, right? I know a formula with all those things, right? And so we'll start with S is C plus E plus P. And then we can plug in things that we know, right? And one clue, right, or one thing that I'm going to look at is because I've got S here, even though I know S is 14,995, I'm just going to write S as S for now, because I know eventually I'll want to collect it with this S. And it just makes it easier. And so I'll just keep it as S is C, which I don't know what it is, right? I'm trying to find C, plus E, which is 0.32 times C, plus P, which is 0.37 times S. So now I've got C's and S's. I know what S is though, right? But for now, I'm just gonna keep them as C's and S's, and then I can move stuff around. Right? So I'm gonna move S's to one side, C's to the other side. And so I have S minus 0.37 S is C plus 0.32 C. If I pull out the common S, right, factor out an S, I've got S times 1 minus 0.37 is C times 1 plus 0.32. One minus 0.37 is 0.63 times S. And then I've got 1.32 times C. Here's a good spot to put in my S because I know it, right? As soon as I only have to put it in once, then I'm satisfied, right? Then I can put it in. But like I said, if you wanted to put it in right away, get rid of it. That's fine too. So here I'm going to do 0.63 times 14,995. Oops. One too many nines in there. It's a really expensive car. 14,995. So this becomes 9,446.85 even. That's nice. 1.32 C. Solving for C, right, I'm going to divide both sides by 1.32. So C is 9,446.85 divided by 1.32. So C is, not quite yet, 7,156.7045. So the cost is $7,156.70. So dealership bought it for $7,156.70, sells it for $14,995 to account for their expenses and their profit. Nice. Any questions about that one? Knowing this, we could figure out how much profit they make, how much overhead they have. We won't, but we could. So let's do a more elaborate example. Oh, I love this example. Cutie Pie Cosmetics Supply. Catchy name. So example 90. Example 90 is kind of kicking it up a notch. So Cutie Pie Cosmetics Supply obtains boxes of hair dye for $230 per box, less 30% and 10%. So keep that in mind. The price is set to cover Cutie Pie's overhead of 20% of the selling price and to provide an operating profit of 18% of the selling price. What should be the retail price per box? I think we can reword that question. What should the retail price be? Right? Or essentially find the selling price, right? That's what we're really after here. Find the selling price. Let's just make a list of all the things that we know, and we'll see that there's kind of a disconnect, right? There's no clear formula that we have to use, and that's because we have to use two formulas, right? Kind of make it work. And so what we're given is that, so Cutie Pie gets these boxes for $230 per box, less 30% and 10%. Right? And so the cost, or the net price, or I guess that makes it the list price anyways. Since I'm doing the given, the list price is $230 per box. Discount 1 is 30% and discount 2 is 10%. We're also given that the price is set to cover Cutie Pie's overhead, so E, of 20% of the selling price, and for profit to be 0.18 of the selling price. And we want to find S. So one way we could do it is we could, well, if I know E and I know P, right, I could say, well, I'm going to start here and say S is C plus E plus P. Right. I want to find S. That's where I'm headed. Right. One way or another, I know what E is, right? That's here. Or actually, we'll do this. And we know that P is this. So once we have S, then we can find E and P, right? Because they each have S's in them. But we can only do that if we had C, right? Then we could solve for S. But because C is unknown, right, we have to kind of figure out, well, C is the cost, right? And so the cost to Cutie Pie's cosmetic supply, Cutie Pie's cosmetic supplies, ugh, hard to say. Right, but that's where that fact comes in, that at the retail level, right? So at the store level, the cost is the same as the net price. And so here, can you guys see that? Yeah. At the store level, the net price is the cost. Right. So if we need C, we could find the net price because we have the list price and we have the discounts. Right. And so we can say, well, N is the list price times 1 minus D1 times 1 minus D2. So N is 230 times 1 minus 0.3 times 1 minus 0.1. 230 times 0.7 times 0.9. 230 times 0.7 times 0.9. Oops. Hello. Is 144.90. No rounding required. So now we know that C must be, right? The cost to buy this product is 144.90. So now we can start at that formula where we started off and just kind of tried to use it, right? And say that S is C plus E plus P. And we're trying to solve for S. Now we know that C is 144.90. I only plug it in because I don't have any more C's in there. And E is 0.2S. And P is 0.18S. So if we collect all these like terms, right, move the 0.2S over to the left-hand side and move the 0.18S over to the left-hand side, we get S minus 0.2S minus 0.18S is 144.90. Again, we can factor out the common S. And so we can say that's the same as S times 1 minus 0.20 minus 0.18 is 144.90. So 1 minus 0.2 minus 0.18. We've got 0.62S is 144.90. So S is 144.90 divided by 0.62. So S must be 233.7096774. So S, the selling price must be 233.71. Let's just talk about just the ROMU and the GPM on here, just because they're kind of quick to get through. Okay. The ROMU is the ROMU, the rate of the markup. Okay. And you'll notice that there's two formulas for the rate of the markup, and whichever one you use is fine, but it's going to depend on the information that you have. All right, so if you know M and you know C, you should probably use the first one. But if you know the gross profit margin, GPM, you should probably use the second one. Right, so it just depends on the information that you have or the information that's the easiest to find. And so we can calculate the rate of the markup, which we call the ROMU. by the raw mu is M over C. So that's on your formula sheet. So the rate of the markup is the amount of the markup. The amount of markup over the cost, right? We've already seen these. Or we can use the raw mu, the rate of the markup is the gross profit margin, and I'll define those in just a sec. The GPM over 1 minus the GPM. It's also on your formula sheet. Where GPM is the gross profit margin. Which we can calculate. The gross profit margin also has two formulas on your formula sheet, right? So this stuff takes up a lot of room on here, but we're not going to use it a huge amount. So the gross profit margin is M over S, right? Same sort of setup. We have the amount of the markup over the selling price. So here, this is the amount of markup over the selling price. Or again, the gross profit margin is the raw mu over 1 plus the raw mu. So they're definitely related. Right. Just looking at these formulas, try to get them on the same page here. They both have M's in there, right? It's just, did you divide by C or did you divide by S, right? Did you divide by the cost or did you divide by the selling price? Let's do a quick example of this, and then we can do markdowns, which is the rest of the section next day. So we'll do a quick example. Example 92. Oops. So a merchant has a selling price of $13,500 for a small boat. The cost to the merchant is $9,950. Calculate the raw mu and the GPM. So here, we're given S is 13,500 and C is 9,950. And we need to find first the raw mu and then the GPM, or whichever one's easiest to find in whatever order. Right. Once we have one of them, we can find the other one. Okay. So if we look at S and C, that's all we know, but that's all we need, right? Because if you look at your formula, oops, then you know that S is C plus M. And like we just said, both the formulas for the raw mu and the GPM use M. Right. M over S or M over C, depending on which one you're talking about. So if we know S and we know C, we can find M. All right, so we have 13,500 is 9,950 plus M. So M is 13,500 minus 9,950. So the markup, the amount of the markup is 3,550. So I'll just start where I'm at on the formula sheet. So therefore the raw mu, and I'll start with that one, which is M over C, is 3,550 over C, which was 9,950. So my raw mu is 0.35678,392, right, or 35.7%. I'm rounding. I've got two options for calculating my gross profit margin now, because I know my raw mu, but I also know the amount of the markup and the selling price. So therefore the gross profit margin is M over S, 3,550 over S, which was 13,500. So my gross profit margin is 0.262962963. And what you can do if you wanted to check these, that they're all related, you could just double check using the gross profit margin. You could calculate the raw mu using this gross profit margin, or vice versa if you wanted to calculate the gross profit margin using the raw mu that you just found. You'll find that they're all in cahoots. On that note, see you guys on Wednesday. Oh, any questions I guess I should ask? No? Get out of here.